So let's suppose I have two objects, object A and object B. And let's suppose object A with mass ma is traveling with the velocity va along the horizontal axis when it collides elastically with the second object that has a mass mb that is stationary. Now we want to derive the following equation. So in part A, we want to derive the equations for the final velocities of the two objects, VA prime and VB prime, after our collision takes place in terms of MA, MB, and VA, where MA and MB are simply our two masses of the object, and VA is the initial velocity of object A before our collision takes place. Now note, we know the second object, object B, is stationary. That means the initial velocity VB before our collision takes place is 0 meters per second. Now, we also know our collision is elastic. So that basically means we have the following two equations. We have the conservation of kinetic energy equation and the conservation of momentum equation. So, this equation basically states that the initial kinetic energies of the two objects before our collision takes place is equal to the final kinetic energy of our two objects after our collision takes place. So left side is equal to the right side. Now we know that the initial velocity of object B, our velocity VB, is 0. So this entire term goes to 0. And notice we could multiply the entire equation by 2 and cancel out the halves. Now if we do a bit more rearranging, we get the following result. So VA minus VB is equal to negative of VA prime minus VB prime. Now VB is 0, like I said before, so this term and this term cancels out, and we can rearrange for VA prime. So VA prime is equal to VB prime minus VA. So let's label this equation as equation 1. It will come in handy in just a moment. Now let's go to our conservation of momentum equation. So once again, the sum of the momentum before our collision is equal to the sum of the momentum after our collision takes place. So notice the VB term once again appears. So because VB is 0, this entire term goes to 0. So we're left with the following equation. Now notice we have VB prime and VA prime. So we have one equation and two unknowns. So in order to solve for one of the unknown, we have to have two equations and two unknowns. So this is one equation and the second equation. So two equations, two unknowns. That means if we take VA prime and plug this quantity in for VA prime in the second equation, we get the following result. So MAVA is equal to MA multiplied by this whole quantity plus MBVB prime. Now notice we have one equation, one unknown, so we can solve for VB prime. So let's multiply the MA out. We get the following result. Now we can rearrange our equation. We get this. So we get MAVA plus MAVA. So this becomes 2MAVA. And this side simply becomes MA plus MB multiplied by VB prime. So we can bring these two masses, the sum of the two masses, to the left side. And we get the following result. So these two guys add up. We get VB prime is equal to 2 times MAVA divided by MA plus MB. So this is one of the equations. This is the equation for VB prime, the velocity of object B after our collision takes place, in terms of the masses and the velocity of object A, given here as VA. Now, we can take this equation and plug this into equation 1. So now we know what VB prime is in terms of our knowns. So we can take this quantity and plug it into VB prime, and that will give us what VA prime is in terms of our knowns. So we take this, we plug it into this, and we get the following result. VA prime is equal to this whole sum minus VA. So now we want to find the common denominator. The common denominator is MA plus MB. So I multiply this term by MA plus MB. I get this result. So now I subtract these two terms and I get the following result. So we get VA prime is equal to VA multiplied by MA minus MB divided by MA plus MB. So we're done with part 1. So we found the two equations for our velocity VA and VB prime. Now, let's go to part B. We want to derive the same equations assuming that the mass of object A is much, much larger than the mass of object B. So we take these two equations and we place them here. So let's place our VA prime equation. So we have the same exact result. Now notice, if we assume that MA is much larger than MB, that means this top term, MA minus MB, is approximately equal to simply MA. For example, if MA is 1000 and MB is 1, then MA minus MB, 1000 minus 1 is 999. So it's approximately equal to simply MA. Likewise, MA plus MB is approximately equal to MA. So we get the following quantity. So this is approximately equal to this. The MA's cancel and we're left with the following result. So VA prime is equal to simply VA, approximately equal to VA when the mass of object A is much higher than object B. And likewise, we take this equation, we place it here. Notice we have on the bottom MA plus MB. So once again, MA is much larger than MB, so we can approximate this to be 2 times MA VA divided by MA. And so the MA's cancel and we're left with the following result. So VB prime is approximately equal to twice the initial velocity of VA. And let's go to the last example, C. Now we want to derive the same equations, assuming that the mass of the second object, MB, is much, much larger than the mass of the first object, MA. So once again, the same exact story. We take these two equations and we use them. So if we begin with a VA prime, we have the following result, and now notice that MB is much larger than MA. So that means this term can be approximated to be 0, so we get the following result. Negative VA MB, the negative comes from the fact that this becomes 0 and the negative is left over, and the bottom becomes MB. The MB's cancel, and we get that the final velocity of object 1 is equal to negative of its initial velocity. So that basically means if we have a very heavy object that is stationary and a second object that is very light comes in, collides, that object as long as this is true, that object will bounce away with the same exact velocity, but that velocity will point in a different direction, in the opposite direction. So likewise, let's look at VB prime. So VB prime, we get this equation. Notice that our bottom simply becomes MB, and we get the following result. So if MB is much larger than MA, that means the numerator will be very small, denominator will be very high, and so a low number divided by a very high number is approximately equal to 0, a very small number. So we see that our second object, if a very light object collides elastically, the second object will not really move, and so the final velocity of the second object will be approximately equal to 0.